Hello friends, welcome to online school. And now let's talk about differentiation of implicit functions. And then here I've said that these are functions which cannot be easily expressed in the form y equal to fx. And then so a point to note is that when we are differentiating these functions, we consider each of the individual terms. And then so from that, let's have a look at an example of implicit functions. Assume you have a function y, or assume you have a function x squared minus 6y cubed plus y being equal to 0. So you happen to note that even when you factorize out this y here, it is very difficult to put this function here in the form of y equal to fx, or putting the variable x on one side and then having one y here being the subject. So how do you differentiate implicit functions? When we are differentiating implicit functions, we consider term by term. And then so let's take an example of this. So you begin by saying, let's introduce the derivative symbol. So we shall have d by dx of x squared, this is our first term, minus d by dx of 6y cubed plus d by dx of a y, and this will equal to d by dx of a 0. And then so what's next after that? After that, we can differentiate each individual term. And so we know that the derivative of x squared, you drop the power and then subtract 1 from the power. So we shall remain with 2x minus. Now, when it comes to this variable here, which is y, remember y, we are considering y to be a function of x. And then so when it comes to this variable here, it means that when you're differentiating this, we use chain rule. And then so you happen to find that this is a constant here, and then the constant, it is the same as being outside this derivative symbol. So we shall have, it's like 6d by dx of y cubed. And then when you differentiate y cubed, we shall get, when you drop the power, which is 3, we shall get 3y squared. But then remember that we are differentiating the function y with respect to x. Since y, it is considered to be a function in terms of x, that's why we are multiplying through by dy dx, and then which is chain rule. And then so we shall have, even this one here, it will be plus dy dx, and then this other side, the derivative of any constant, it is a 0, being equal to a 0. And then so what's next? After that, we can collect like terms, the terms with dy dx, and then these other terms. So we shall have 2x crossing going the other side. So we shall have negative 6 times 3, it will be negative 18. So we shall have negative 18y squared, negative 18y squared plus dy dx plus dy dx being equal to a negative 2x, alright, like that. And then so we can factorize out the dy dx in this part here. So we shall have negative 18 y squared plus a 1, and then the whole of this being multiplied by dy dx being equal to a negative 2x. And then so on proceeding, or finally we shall get to our derivative, which is dy dx being equal to negative 2x, and then we can divide through by this negative 18y squared plus 1, so divided by negative 18y squared plus 1. Alright, and then by so doing, this is our derivative function for the given function, which was, this is our derivative function for the given function, which was an implicit function. This is our dy dx. And then so after that, and now let's have a look at another example. Assuming that we have our function, we are also going to differentiate explicitly. Assuming we have our function y squared over x plus y being equal to 2x. And then so now for this one, before we differentiate, we can first multiply through by this x plus y to eliminate it from the denominator. So we shall have y squared being equal to 2x into x plus y. And so you happen to find that when you multiply it here, it will cancel with that, and then it will only remain on this side here. And then so we shall have this simplified further to y squared being equal to 2x squared plus 2xy, alright, like that. And then so remember we said that when you're differentiating implicit functions, we differentiate term by term, or we consider each of the individual terms. And then so from that we shall have, we can introduce the derivative symbol. So we shall have the derivative of y squared being equal to the derivative. So remember we say that if at all we have a constant here, it is the same as saying that twice or 2 multiplied by the derivative of x squared plus this other 2 here multiplied by the derivative of xy. Alright, and now after reaching that step, we shall have the derivative of y squared. So this one here, it is going to be, we can first drop the power and then we subtract a 1 from the power. So we shall have 2y multiplied by dy dx. Remember we said that for y, since we are considering x, we are considering y to be a function of in terms of x. That's why we use chain rule at this part here, and then so we shall have 2y multiplied by dy dx, because we are differentiating our function y with respect to x. So being equal to 2, then when you differentiate the derivative of x squared, we know that when you drop the power here, you shall have 2x. And then even here, it is the same as having dx dx. But then the x dx, it is the same as a 1. So that's why we leave it out. Then plus 2. Now this other term here, you happen to note that this is a product. This is a product of x and y. So we shall use product rule, which says that v du dx plus u dv dx. And then so taking my v to be the x, so we shall have x dy dx plus my v is x and then my u is y plus u, which is y dx dx. Alright, like that. And then so you happen to note that if at all it was a quotient, x over y, we would have used quotient rule. But then since it is a product, we use product rule, and then you have simplified it to that. So we shall have 2y dy dx being equal to 4x plus, so these two can enter and multiply every time here, plus 2x dy dx plus 2y. Alright, like that. And dx dx, it is the same as a 1. So then from that we can collect like terms, and then on collecting like terms we shall have 2y dy dx minus 2x dy dx being equal to 4x plus 2y. Then so after that we can factorize out dy dx here, and then we shall have 2y minus 2x of dy dx being equal to 4x plus 2y divided by, or we can first leave that out. So after that we can come here and we write our formula for dy dx. We can divide this both sides. So we shall have dy dx being equal to 4x plus 2y, this divided by 2y minus 2x, and then so this is our dy. And then so you happen to find that this one here, it can reduce because you have 2, which is a common term in the numerator and the denominator. So we shall have 2x plus y over y minus x. And then so this is our derivative for the previously given function. And then so hope all is clear. And then so that's how we differentiate implicit functions. And then so yeah, I can leave some trial questions. We can have some trial questions aside here. And have some trial questions. And then so we can have question number 1 as, x over y plus y over x being equal to a 1, like that. And then so that's the first question. And then we can also have root x plus root y equal to a constant 10, that one there. And then so hope we can also have, we can try out x squared y minus y cubed being equal to 5x. Right, so we can try out these questions, and then so if at all any of them fails to come out or it's kind of stubborn, you can comment in the comment sections. And then at the end of this topic, which is differentiation, I'll make a video for all the solutions of the given questions in the various sections.